In 2020, People Tech Group launched their Automotive Center of the Future, also known as the ACF. The ACF focused on advancing human-to-vehicle interactions by leveraging the latest technologies with the help of our valued automotive industry partners. Project Dial, which stands for Driver Interaction, Analytics and Learning, are the first fruits of this collaboration within the ACF. It provides a platform for exploring a host of driver experience enhancing use cases. The Dial TM project by PeopleTech aims to secure connectivity and data exchange between HMI and cloud, to significantly improve the understanding of user interactions and enhance future HMIs. It aims to learn driver-specific usage patterns and suggests or automates the process. It reduces drivers' distraction and workload. It understands demography-based HMI, app usage patterns, and provide enhanced solutions. It helps car makers optimize their infotainment solutions and investments. And finally, it enables flexible ecosystems to deploy custom scenario definitions for edge analytics as well as direct data collection. Now let's take a closer look at the contents of Project Dial. Project Dial has an in-vehicle dial app that does non-intrusive data collection from the infotainment HMI, vehicle data bus, and other vehicle sensors and securely pushes the data to AWS IoT. All the private and sensitive information is encrypted and red-channeled for added security. So what's in it for the OEMs? OEMs can harness the data collected to make major decisions at various stages of product development. For example, the product design team can understand if they need to invest their time and effort in building certain physical keys which are minimally used. Or a systems team that can understand how their software apps are performing and how often certain apps are crashing. The UX designers can study the data collected and design the in-vehicle experiences to minimize driver workload and maximize usability. And with respect to post-sales activities, dealerships can, for example, alert their lease vehicle users on possible part failure well in advance and avoid higher closure costs. Here you see an example of some of the vehicle data points that can be collected. All the data that is private to the user, for example, the VIN number, precise location, etc., are obfuscated and a generated key is used for all analytics purposes. Furthermore, none of the user-specific data is stored on the cloud directly. Moving on to the in-vehicle components. Dial-App, an Android or native application, captures various user interaction data points and vehicle data. Dial-App then uses AWS Mobile SDK for Android for secure connectivity and authentication to AWS Cloud. For the AWS Cloud components, all the head units connect to this AWS IoT core. The Amazon Kinesis data firehose is then streaming the data topics published by various edge devices and then delivered to Amazon S3. AWS Lambda is used to deploy custom functions, whereas SageMaker for ML models. Amazon DynamoDB is used to store data logs, decision logs, and event history. AWS Athena makes Dynamo datasets available for QuickSight's analytics, and Amazon SNS is the notification service to push notifications or suggestions directly to the user. So let's see Project Dial in action. This is the real-time data collected directly from the hardware, and in this example, from the in-vehicle application. As mentioned previously, QuickSight Analytics is used for data visualization when the data has been extracted from the hardware. All the data is coming from the devices and are sent to the AWS IoT core. And here's where you'll apply the AWS IoT rule and route it to the Kinesis and S3 for analytics, logging, and ML purposes. In DynamoDB is where all the bus parameters reside, and here we can see that the vehicle IDs are properly encrypted. And taking a closer look in the logcat, here we will find all the data related to error incidents, as well as the associated description of set errors. Let's take a look at how some of these analytics are being visualized in a little more detail. These are some of the driver workload and usability related analytics that can be derived. First, frequency of interactions based on vehicle speed or state. How long users spent time on various applications are also analyzed. Application and time spent is then projected based on a heat map. Frequency of general screen interaction based on vehicle state and speed. Types of apps interacted with and event types based on vehicle state and speed. And for the final example, we look at the error count or type of errors occurring within the infotainment apps. and we look at the error count as a sum specifically. Having access to all these datasets, we can take our ML models and put it on top of it, making the HMI more usable by automatically populating the favorite app list for the user and making it available at the top screen for quick access. We can also predict the vehicle wear and tear. For example, we know the vehicle mileage, the tire pressure, the inflation and deflation curve, and we can then make a prediction of the overall tire health. Now, let's see what's going on at the edge. As soon as the device or emulator is turned on, it connects directly to the Wi-Fi network. And once it's connected to the internet, the dial-up securely connects to the cloud and obtains a packet during handshake containing the configuration parameters, for example, the frequency of packets, what data points to collect from this particular vehicle, etc., which we can see right here in the logcat. At this point, the cloud also pushes the favorite apps for this specific user, which is derived based on the usage patterns recorded so far and helps in reconfiguring the HMI to make the UI more usable. Also note that all the screen interactions are captured along with all the requested vehicle data points. If there are any application crashes, the errors are captured and pushed to the cloud for further ML processing. Now, we're going to open this dummy app called testcode, in which we're going to crash the app intentionally. Now, the app has now crashed and the logs are being captured in real time and it's being pushed to the cloud. So let's check out what the error was. Here, as you can see, the tombstone says that the error was an arithmetic exception which happened in the same testcode package. As the user interacts with the HMI, the interactions are captured and pushed to the cloud. For example, here we're going to interact with the media application. Here you can see that we have captured the data from our transition. We started the transition from car launcher package, which contains the app grid activity, and then we transitioned into media activity, which is part of the media package, along with the timestamp at which this event took place. Now we will try and simulate some CAN parameters such as vehicle speed, ignition state, and gear. Here you can see that the device is in on state right now, and the default value for speed is 0. We will change that to 46 km per hour. And as you can see here, we've successfully changed the value of speed to 46 km per hour from its default value of 0. And now we'll change the ignition state from on to start and the current gear from park to drive. And let's see if the same thing is being captured or not. As you can see, the ignition state has changed from 4 to 5 and the current gear's value has changed from 4 to 8. And finally, we'll try and simulate the fan speed. As you can see, it's currently sitting at medium speed, but we'll change that from 3 to 5. And as we change it on the emulator on the screen that you see right now, let's see if that data is also captured. And there you have it. The application has successfully recorded that the value changed from 3 to 5. As you can see, Project Dial opens up a world of driver experience enhancing opportunities. And PeopleTech Group, along with its automotive industry partners, plan to explore this new world, bringing powerful new features and business models to life on this platform.